found v, but this time it is reverse. We have v, which is imaginary function, which I told you, f equal to f of z equal to u plus iv, right? We had u, we had to find v. Now we have v, we have to find u, right? And this is a Cartesian equation. Then we have to prove this is analytic. Show is this analytic, harmonic. We have to prove these two and find the analytic function. Analytic function means finding the opposite function which is there. Like we have to find u. So that is an analytic function. So let's proceed ahead. So first and for most easiest thing we can do is finding, like checking if it's harmonic. Like del square is equal to del square by del x square plus del square y by del square by del y square. So this is gradient function, by the way. Okay, wait a second, there is light reflection, I guess. So wait a second. Okay, so this is gradient function, by the way, delta square. So what we do here is so this is this function. Now whatever our function is, like here we have v, we just have to multiply del square by v and we would find stuff. So it would be like this should be equal to 0, by the way. No, by the way, like this del square v should be equal to 0, which is equal to del square v by del x square plus del square v by del y square. Okay. So so harmonic is like square function, I previously said. So we have to take double derivative or square derivative of the thing. We have only two functions, like two variables, u and v are functions of f of function of x and y. So we have to take derivative with respect to x and derivative with respect to y. So we are doing that. So when we add these, it should be 0. Okay, like they were opposite, right? So when we add those, it should be 0. And by the way, I forgot to tell you, like a CR equation for Cartesian form is like this is Cartesian form, right? So we have to check this is analytic. Analytic is checked by CR equation. CR equation here is del u by del x. Wait a second. Where is this? Focus is gone, I guess. Del u by del x equal to del v by del y. Del u by del y equal to del v by del x minus del v by del x. Here we go. So now what did I do is, so this needs actually v. Okay, so I told you f of z equal to u plus iv. Okay, there are two functions. Now we have to build relation between u and v. So del u by del x is equal to del v by del y, because u and v are f of function of x and y. So it is first variable is x in function of u, and first variable in function of z is u. So u and x are related. So we do del u with respect to del x. So this is related and this is correct. And del v by del y, because v is second function in f of z, imaginary one, and in this also imaginary one is y, and second function is y in v function. So second function, first function related, their derivative is equal to is positive. But when we swap this, like we did this one time, like derivative of this, derivative of this. Now what is the possibility? Like we do reverse, like we exchange the with respect to denominators. So we exchange the denominators. This is opposite stuff. Now what happens is, wait a second for real. Wait a quick second. I guess I'll be back. Wait a second. Wait a second, what is happening? Yeah, so we are back. So what happened here is, uh, yeah. So we swapped the denominators, like that was the only possibility. There are two variables, two functions and two variables. Now we swap these variables with respect to derivations. So we swap these, we exchange this. This is another possibility, but this is opposite. Like y was a second function, x was first function, u was first function, while x was first function, v was second function. We exchanged the function, we tried it, so we did the opposite thing. To balance that, we gave a opposite sign, which is minus sign. From plus sign we go to minus sign. This was opposite to this, and this was swapped, so this is opposite. Opposite cancel, balanced. Okay, this is how you can remember the CR equations. Now now I would tell you the Milne Thomson Cartesian form stuff. Okay, Thomson Cartesian form. Why do we need this? I told you we need analytic function. Analytic function is, first actually we need Milne Thomson analytic function, which is we only have v now. Can we do anything with this for finding CR equation? No. We need u. There is u. So how would we find u? Analytic function. U is the analytic function, opposite function of v in f of z. So to find u, we need Milne Thomson, and after finding that, we can do CR equations. To do Milne Thomson, what we need is integration phi 1 z comma 0 this is actually, I have to tell you, this would have been minus if this was u. This is v, so this would be plus I would be there because this complex function, every time I would be there. Integration phi 2 z comma 0 dz. Okay, now what happens is here, wait a second. So what happens is here is sorry, wait a second, wait a quick second. So phi 1 here is, since we have to take first function is related function. V was related to y. I told you, second function in f of z, second function in v, second variable in v function. So both second. So I took phi 1 as del v by del y. Phi 2 would be unrelated one. Simple, del v by del x. So here we are. So we need del v and del y anyways. I'm sorry for coughing. Ouch. We need at least one derivation of that. Here also we need del of this. Here also we need del. We need derivative of this everywhere. So let's go for it. First we have to find harmonic. This is the easiest one. Okay. So del square v by del x square. How we can find it is, wait a second. Del square v by del x square is equal to del by del x, del x. We will take it out once because square means multiply to itself 2 times. 2 times derivative. Okay. So first time derivative, then we take the function del v by del x. Its result we do derivative. Okay. For that we have to first find del v by del x. What is v? We have to multiply this to both of this. Okay, this two and this two. Okay, to multiply this to both of this. Now what we do is del of ex multiplied to x sin y, e raised to x to sin x sin y would be x e raised to x sin y plus e raised to x. I would multiply to this cos y cos y. It would be y e raised to x cos y. Now what I do is we are taking derivative of this. Okay, so this is del x. Now what happens is here is the e raised to x is common, right? I know. Okay, so this is gonna be tough, This is gonna be tough, not easy. So what are we gonna do with this? So when we are okay, I have to explain you this. Del x means x take derivative others are either constants or coefficient, depends on if constant for alone and coefficient if it is like coefficient when it is multiplied with x term. So wait a quick second, I need my gloves, I guess. I don't know, maybe I should wear gloves or not. Let's not wear gloves. So this is like that, okay? Del v by del x equal to this stuff, okay? Now what we would do is okay, so x e raised to x is totally x term, okay? Sin y is y term. So okay, I have to explain you another thing. D k f of x, let's k be a constant, d of x equal to k df of x by dx, okay? So if coefficient into variable, you have to take derivative, that can be coefficient taken out and multiply multiply that coefficient after you have taken derivative of the function directly, okay? And also have to tell you that derivative of u into v, let u be f of x and v be g of x. Like these are two different functions of x, okay? Now d by dx of u into v is d by du by dx into v plus u into dv by dx. Understood? The derivative of u into v is equal to u derivative of v plus v derivative of u, okay? So now what we do is, because this is x term, okay? So x term should be differentiated, okay? And y terms should be y is other term, so it can be constant or coefficient. Is it alone? No. So no constant. It is coefficient because it is multiplied with y x terms. What do we do with coefficient? Take it out, multiply to the derivative result later. Derivative of variable. So there are two variables multiplied now of x term. Now what we can do is this du into v, like two functions, if they are multiplied of some variable, okay, then it is equal to derivative of one into other other function plus derivative of previous function intact into derivative of uh, wait a second, derivative of first function into second function plus derivative of uh, second function into first function. Okay, like which was not derivative earlier, you have to take derivative, and which was intact earlier, you have to take derivative of it. Okay, just understand this. Okay, see, one function you take derivative, keep other intact, multiply them, plus then keep the intact, take the intact one and do its derivative, and which was derivative previously, keep it intact and multiply them and add. Okay, so what would happen here is, I hope my audio is audible. Am I audible? So yeah, uh maybe I would continue in shorts, or maybe I would continue a little later. I guess I have to take a break. Okay, I have to take a break. So yeah, see ya. Thanks for watching. Like and subscribe. See you next time. Bye.